heating, ventilation, and air conditioning, HVAC, systems, creating comfortable and efficient indoor environments. Introduction: heating, ventilation, and air conditioning, HVAC, systems are the unsung heroes of modern buildings. They play a pivotal role in maintaining comfortable indoor temperatures, regulating air quality, and ensuring energy efficiency. In this video, we'll delve into the design and operation of HVAC systems in buildings, with a primary focus on optimizing energy efficiency and enhancing indoor air quality. The importance of HVAC systems. HVAC systems are the heart and lungs of any building, providing the following essential functions. 1. Heating, keeping indoor spaces warm during colder months. 2. Ventilation, supplying fresh outdoor air while removing indoor pollutants. 3. Air conditioning, cooling indoor spaces during hot weather. Designing an efficient HVAC system. Load calculation, properly sizing the HVAC system is crucial. Oversized systems can lead to energy waste, while undersized systems won't provide sufficient comfort. A thorough load calculation considers factors like climate, building size, occupancy, and insulation. Zoning, dividing the building into zones allows for tailored temperature control. This prevents overconditioning of unused spaces, reducing energy consumption. High-efficiency equipment, selecting energy-efficient HVAC equipment, such as heat pumps, boilers, and chillers, can significantly reduce energy consumption. Look for systems with high seasonal energy efficiency ratios, SEER, or heating seasonal performance factors, HSPF. Variable speed components. Incorporating variable speed compressors and fans allows the system to adjust its output based on demand, resulting in lower energy consumption and enhanced comfort. Smart controls. Modern HVAC systems integrate smart thermostats and controls, enabling remote monitoring and optimization. Machine learning algorithms can predict usage patterns and optimize settings for energy efficiency. Heat recovery. Implementing heat recovery systems can capture and reuse energy that would otherwise be wasted, such as recovering heat from exhaust air to preheat incoming fresh air. Improving indoor air quality. Filtration. Installing high-efficiency air filters can trap particles and allergens, improving indoor air quality. Regular filter replacement is essential for maintaining efficiency. Ventilation. Adequate ventilation is crucial for diluting indoor pollutants. Use demand-controlled ventilation systems that adjust air exchange rates based on occupancy and outdoor air quality. Humidity control. Maintaining the right humidity level is key to comfort and indoor air quality. Humidity sensors and humidifiers/dehumidifiers can help achieve optimal levels. Air quality monitoring. Real-time air quality monitoring can detect pollutants like CO2, VOCs, and particulate matter. This data can trigger HVAC adjustments to ensure healthy indoor air. Energy efficiency and sustainability. Energy recovery ventilation. Incorporating energy recovery ventilators can transfer heat or coolness between outgoing and incoming air streams, reducing the need for additional heating or cooling. Renewable energy integration. Consider pairing HVAC systems with renewable energy sources like solar panels or geothermal heat pumps to reduce reliance on fossil fuels. Regular maintenance. Scheduled maintenance is vital for keeping HVAC systems running efficiently. Cleaning coils, checking refrigerant levels, and sealing ducts can prevent energy loss. building envelope improvements, enhancing insulation, sealing air leaks, and using energy-efficient windows can reduce the HVAC system's workload, further improving efficiency. Energy-efficient HVAC. Energy-efficient HVAC options are designed to provide effective heating, ventilation, and air conditioning while minimizing energy consumption and reducing environmental impact. These systems and technologies prioritize efficiency, which can lead to significant cost savings and a reduced carbon footprint. Here are some energy-efficient HVAC options to consider. High-efficiency HVAC systems. 1. Heat pumps. Heat pumps are highly efficient for both heating and cooling. 1. They extract heat from the air or ground and transfer it inside or outside the building. 2. Variable speed technology. HVAC systems with variable speed compressors and fans adjust their output based on demand, reducing energy consumption during periods of low load. Geothermal heat pumps. 1. Geothermal heat pumps, also known as ground source heat pumps, utilize the stable temperature of the earth to provide heating and cooling. 1. They are extremely energy efficient and can save significant energy costs over time. Ductless mini-split systems. 1. Ductless mini-split systems are highly efficient and provide zone heating and cooling. 1. Since they don't require ductwork, there's less energy loss due to air leakage. Smart thermostats and controls. 1. Smart thermostats like Nest, Ecobee, and others learn your heating and cooling preferences and adjust settings for maximum efficiency. 1. They can be controlled remotely and integrate with home automation systems. Energy recovery ventilation, ERV, and heat recovery ventilation, HRV. 1. These systems recover heat or coolness from outgoing air and transfer it to incoming air, preconditioning the fresh air and reducing the load on the HVAC system. Zoning and dampers. 1. Zoning divides a building into separate areas or zones, each with its own thermostat. 1. Dampers in the ductwork control the airflow to each zone, allowing for precise temperature control and energy savings. Insulation and air sealing. 1. Proper insulation and air sealing of a building envelope reduces the workload on HVAC systems by minimizing heat gain in the summer and heat loss in the winter. High-efficiency filters and air purifiers. 1. High-efficiency filters can improve indoor air quality while minimizing the system's energy consumption. 1. Air purifiers with HEPA filters can further enhance air quality. Solar HVAC systems. 1. Integrating solar panels with HVAC systems can offset energy consumption. 1. Solar-powered HVAC systems generate electricity from sunlight, reducing reliance on the grid. Demand-controlled ventilation, DCV. 1. DCV systems adjust ventilation rates based on occupancy levels, optimizing fresh air intake and energy use. Programmable HVAC controls. 1. Programmable thermostats and scheduling options allow you to set temperature setbacks during unoccupied periods, reducing energy consumption when heating or cooling is not needed. Regular maintenance. 1. Routine maintenance, as mentioned earlier, is critical for ensuring the continued energy efficiency of HVAC systems. It's important to note that the most effective energy-efficient HVAC options for your building will depend on factors such as climate, building size, usage patterns, and budget. Consulting with an HVAC professional can help you choose the most suitable and cost-effective solution for your specific needs while considering long-term energy savings and environmental benefits. Conclusion: HVAC systems are integral to our daily lives, ensuring comfort and indoor air quality in the places we live and work. By investing in well-designed, energy-efficient HVAC systems and prioritizing indoor air quality, We can create sustainable and healthy indoor environments while reducing our environmental footprint. Regular maintenance and embracing innovative technologies will continue to drive improvements in HVAC efficiency and performance, making our buildings more comfortable and sustainable for generations to come. Thanks for watching.